Let's talk about running large language models locally. So let's say you purchase a server with a GPU in it. It might be something like an RTX 4090, a 3090, an A100 would be a little bit more, even an H100, even more than that. But let's say you purchase it and run it locally versus use an online solution and provider. Okay, so let's just compare some of the costs for that. Let's say the hardware for this with kind of a consumer grade gaming GPU might be something like $5,000 for this server, and that's a one-time cost. And then let's say you have something like electricity that's, let's say you're using about 400 watts on average. Okay, and then we have, about 8,760, and that's hours per year. Okay, and then let's say that is also multiplied by something like 12 cents per kilowatt hour. Okay, so that's going to be electricity cost. And then let's say we go for 3 years. So let's just look at a 3-year cost. Okay, so we have this server, it's a one time for 3 years. Okay, and then let's go on to the number of tokens that we would generate from this. So if I have, let me go ahead and get rid of that per year. Okay, and then tokens. Okay, and let's say there is, we're running the Mixtral model. We might be able to do about 50 tokens per second on that as a rate. And let's say we have a 20% utilization rate. And there's going to be 3.15 e to the 7th seconds per year. And let's say it's times 3 years. Okay, so all of that works out to be about 1 billion tokens that you are generating or reading into the model. Okay, so inputs or outputs. So you sum all of this up with the $5,000, and the electricity is going to be about 1,261. You add all of that up for the billion tokens, the total cost is going to be about 7,261. Okay, and it's also kind of a fixed resource, so if you overload the server, you need more out of at certain times than others. It's not elastic like online computing. And then let's just compare that to something like the GPT-4 from OpenAI. It's about it's about 6 cents per thousand tokens, and then it's 12 cents. These are the inputs. Okay, and then per thousand, it's 12 cents for the outputs. Okay, and you typically assume, a 3-to-1 or something like that. I'm just going to assume, let's say, 800 million input tokens and maybe 200 million output tokens over 3 years. And then that works out to be $72,000. So here you can see, okay, this right here, if you host it locally versus go through OpenAI, they're going to be coming out with better models. The quality is going to be higher, and we'll see some of the benchmarks on that, what you can host here, maybe with a Mixtral model versus GPT-4, and just how those compare in terms of cost. But we also want to run locally to see if we're going to be able to get good performance off of certain types of hardware. So here's a 3070 GPU and then a 3090. This one has 24 gigabytes of VRAM, that has 8 gigabytes of VRAM. We're going to test a few different models here. Okay, a Phi, a Mistral, Gemma, Mixtral. And then we'll also have some additional context to each of these. And you can see when it doesn't fit in the VRAM, okay, we're going to see a very large time here with the Ollama server. It has to run more of that in CPU or swap out the memory into the GPU. So with a sufficient memory here, you get fairly good performance in terms of the total amount of seconds it takes to run that. We're going to do some benchmarking just to be able to generate these for your own hardware, just to see how well it runs on some of these models. So let's go to the course website. Now I'm just going to show this module that we're going to go through, this LLM with the Ollama Python library, how to first of all run some of these models locally and then perform this benchmark. So if you'd like to follow along, there is this website here. Okay, this is the link to it. You can come to the Data-Driven Engineering course. All right, and then scroll down and you will see this large language model off to the right, and select that and you'll come to this and you get the Jupyter notebook here, or you can't really run it in Colab without the Ollama server. So this link is here just so you can view the notebook. You really shouldn't run it through Google Colab. Okay, so let's go to this exercise. And the very first thing we want to do is pip install and do Ollama. Okay, so pip install Ollama, and this is going to be the very first thing that I want to do. I want to check to make sure I have Ollama installed and I have the latest version. And then what I can do is go to the next one, and this one I need to import Ollama, and then I'll say ollama.pull, and I want to get the Mistral model. Okay, you only have to do these once. It'll install it onto the Ollama server, and if you open up a command prompt, you can also go ollama list to be able to get the models that you have available. Okay, so I just updated that one 6 seconds ago, and you can see the size of the model. And if I run it here, I'll also get some additional information as well. So let's go ahead and just list the model, and you'll see here it gives the model name, when it's modified, the format, how many parameters as well, the quantization level, etc. Okay, so a little bit more information about the models that are running through Ollama. Okay, so now we want to use a generate function. Here's a question: how can LLMs be used in engineering? Okay, so let's go ahead and use the generate function. There's also a chat function. We just need fewer options on here because we're not loading in conversation history. Okay, so here's generate, and we'll use the Mistral model, and this will load the Mistral model about 4 gigabytes, and then run this prompt and generate a response. Okay, so here is our response. LLMs, okay, Master of Law degrees, okay. Okay, I didn't quite get that right. Okay, maybe I'd have to say large language models. Okay, so change that a little bit. If you have something like Mixtral or others, sometimes they do a better job at understanding the correct meaning of that, obscure ones versus others. Okay, so here's large language models, and it gives some suggestions on how those can be used. You can see it ran fairly quickly here on this 3070 NVIDIA 3070 GPU. Okay, so now we also have the chat function, and this one will retain memory of prior prompts, while the generate function does not. So we have to put in the memory, but it allows us to put that in. Here is the prompt: what is the capital of France? And the response, okay, if I generate this, if I say role is user, content, prompt 1, and if I run this, okay, and get the response with the message and content, all right, it will print out R1, and I'll be able to see, what is the capital of France. But let's say I wanted to ask a follow-up question as well, and of Germany. Okay, so let's get a response from this as well, and we'll also use Mistral for this one. And we'll say prompt 1, we're going to feed that one in, then we'll have the assistant, and this is going to be our response. And then we want to have prompt 2, this is the follow-up question as well. All right, and then we're going to get our response, get our content, and then we'll print R2. Okay, so it's going to run now. It'll say the capital of France is Paris, and then the capital city of Germany is Berlin. So if I just loaded this question alone, it wouldn't have known that I'm talking about the capital cities of these countries. And so it allows us to feed in some of these back and forth conversations with the assistant and then provide this additional context based on what was already answered. All right, so there's also some streaming responses as well, so that text appears in pieces as it is generated. And this can improve the perceived responsiveness of the LLM, especially as you can start reading it as it's generating. Okay, so how can LLMs improve automation? All right, we're going to create up a new stream, and we'll have chat. And the only difference here is that we're going to say, we're going to have content prompt, and then here we'll say stream equals true. Okay, and then the next part we'll set up a for loop, so as this arrives we'll process each chunk in the stream, and we will print chunk with our message and content. Okay, and it'll have end, and then flush equals true. All right, so let's go ahead and run this one. You can see that now it's streaming it to my notebook, so it's going to generate this, and you can see it is arriving as those are generated. Okay, so this there's also some evaluating the model performance. We want to look at how to generate with a number of different models. So let me go ahead and just start running this. Here's our original question: how can data science techniques improve predictive maintenance of rotating equipment such as pumps and turbines? We'll also put in some context as a separate test, so a little bit longer of a prompt. It's maybe generated from a RAG solution, retrieval augmented generation, that gives some additional context to the question. Or sometimes this context grows as you increase the number of chat messages and responses as well. So we just want to test a simpler question right here, and then one that's just a little bit more complex and longer. All right, you can also select the models that you want to test. I have the Phi model, the Mistral, and the Gemma. Only use the Mixtral if you have maybe a little bit more substantial of a GPU. It'll take quite a bit of time if you don't have a dedicated GPU. Okay, so here is the time that it's taking. Now some of it's going to be loading time. The Phi model might have taken more because of loading, so we'll account for that versus the calculation time. Okay, you can see the Phi model here, 3.6 seconds versus here with the shorter context window, a little bit shorter, so there's something else happening there in terms of the processing. Okay, and then it's going to finish up with the Gemma model plus the context, just like these are the contexts right here. And then it'll generate a plot. So it's one way to look at these benchmarks on your own computer and just say, okay, how is it doing with these different models? You obviously want to evaluate the quality of the response, but this just shows an example of a simple benchmark. And then I'll show some more complex ones after this finishes. So the Gemma model is taking just a little bit longer. This is the largest one of the three. It's produced by Google. DeepMind, and this one, the Mistral model is fairly good. Mixtral is even better as a mixture of models. Okay, it looks like my GPU was not happy with me on this. Okay, we'll see if it recovers here. And it looks like it has. And so it's going to generate a figure for me. And it looks like it's all locked up right now. Okay, and here are the results that it generated. And let me go ahead and bring those up just as a window to see the load duration. It looked like the prompt rate got a little bit slower here for the Gemma Plus, the context, but the evaluation rate was right around 50 tokens per second. Some of these are very fast, like the Phi model plus the context. The prompt rate was very fast. Okay, you can see here it was on average in the hundreds. These were very fast. I'm not sure if the timing was off a little bit on this. I'm not exactly sure. Okay, but you can see the load duration, just how long it took to load the model and then to process the prompt, and then the evaluation in terms of the rate. Okay, I'll go ahead and close that, and then let me go ahead and just bring this other window over. So these are benchmarks of AI models and hosting providers. And this will change as new models are released. This is a very nice website that allows you to drill down on certain models. So let's say, for example, you're interested in the Mixtral model. All right, and it's just going to highlight some of these, like the quality, the speed in terms of tokens per second. Higher is going to be better. And then the cost. Okay, this is the price. Lower is better. You see some of the higher priced ones are going to be like the GPT-4s are going to be higher. You know, the price, you got the Cloud 3 Opus. Here's the GPT-4 Turbo, Mistral Large. Those are going to have higher qualities in general, but higher costs as well. Okay, and then we see a quality comparison by ability, general ability. These are on different benchmarks. And this is more of an aggregated one right here. Here's some specific benchmarks like the MMLU, the MT bench, and then human evaluation as well. Okay, so many good analyses here, benchmarks. You want to run some of them, these benchmarks on your own computer, but also to see some of these hosting services and how it compares. So you can see Mistral here. You want to get the ones in the green box. This is generally the best in terms of quality versus context window. Okay, and then we see quality versus price. Okay, here's the Mixtral model over here. Okay, pricing, input and output prices as well. Okay, there's your Mixtral model right here. Okay, and then performance summary. All right, there's Mixtral there as well. And then here is throughput versus price as well. Okay, again, in the green is where you want to be in terms of the quadrant. Here's Mixtral as well. So you can see, a lot of companies have gone to the Mixtral model, especially with RAG-enabled solutions that improve the quality. And you can run those locally. As we mentioned, there's a big price, advantage to doing that. And, so it just really depends on your solution, what you're trying to do, but often it's going to be a 10x decrease in cost to host it yourself and run it yourself versus use one of these providers. But those costs may drop as there's more competitors and large language models continue to improve in ability and there's more competition in the market. I hope you've enjoyed this discussion. As a next tutorial, I hope you'll come to the course website and look at some of the additional content. The next one is going to be on using RAG solutions with your large language model to improve the context that you feed to the large language model, and with ChromaDB as a local option, or you could use others as well. But it'll show how to do this step by step with a local solution to have RAG incorporated with the LLM to improve the effectiveness of the large language model.